Dear students, in today's video session, we shall learn about solving assignment problems. For example, a problem of assigning the n jobs to n persons at a minimal cost is an assignment problem. Similarly, a problem of assigning the n jobs to n machines is an assignment problem, and so on. To solve these kind of problems, we use a method called as Hungarian method. To illustrate this method, we shall solve few problems. Consider the following problem. A certain equipment needs 5 repair jobs which have to be assigned to 5 machines. The estimated time in hours that each mechanic requires to complete the repair job is given in the table. That is, to process the job J1, it requires 7 hours in machine M1. To process the job J2, it requires 5 hours in the machine M1, and so on. Now, assuming that each mechanic can be assigned to only one job, we have to find the minimum time of assignment. Here, we shall write the same table in the simpler manner like this and solve it by Hungarian method. Now, consider the lowest cost in every row. In row 1, 5 is the smallest. In row 2, 7 is the smallest. In row 3, 4 is the smallest. In row 4, 3 is the smallest. In row 5, 4 is the smallest. Choose the first row and subtract 5 from all the elements in that row. Then we get. Now choose the second row and subtract 7 from all the elements in that row. Choose the third row and subtract 4 from all the elements in that row. Choose the fourth row and subtract 3 from all the elements in that row. Choose the fifth row and subtract 4 from all the elements in that row. Similarly, we can calculate column wise, that is, choose the least numbers in every column. In column 1, 0 is the least number. In column 2, 0 is the least number. In column 3, 0 is the least number. In column 4, 1 is the least number. In column 5, 2 is the least number. Subtracting 0 from all the numbers in the first column, we get. Subtracting 0 from all the numbers in the second column, we get. Subtracting 0 from all the numbers in the third column, we get. Subtracting 1 from all the elements in the fourth column, we get. Subtracting 2 from all the elements in the fifth column, we get. Hence, we have obtained a simplified table for further calculations. Choose the row or column having only 1 0. Since row 1 has only 1 0, let us choose this row. Mark the 0 in this row. Block the other 0 elements in the marked column. Now, row 2 contains single 0. Let us choose this row. Mark the 0 in this row. Block the other 0 elements in the marked column. Row 3 has no more zeros. Next, row 4 has single 0. So, therefore, choose this row. Mark the 0 in this column. We do not have any zeros to block in the marked column. Now, row 5 has 2 zeros. Hence, do not choose this and start analyzing column wise for single zeros. Now, column 1 contains single 0. Choose this column. Mark the 0 in this column. Now block the other 0 elements in the marked row. Now we find that all the 0 elements are covered. The marked 0 elements indicate that we can go for assignment, that is, M1 can be assigned with J2, M2 can be assigned with J3, M4 can be assigned with J5 and M5 can be assigned with J1. But this assignment cannot be considered since M3 has no assignment. This implies that we have to modify the assignment. For this, we have to draw lines covering all 0 elements. To know how to cover 0 elements, we have to select appropriate rows and columns. For this, choose the row which does not have the assignment, that is, row 3 is chosen and indicate with a tick mark. Now select the column of this row that contains 0, that is, column 3 is chosen and indicate it with a tick mark. Now column 3 has marked 0 in row 2. Hence, choose row 2 and indicate it with a tick mark. So no more zeros in row 2, therefore stop marking. Row wise cover the rows without tick marks by using straight lines. Column wise cover the columns having tick marks. Now choose the numbers which are not covered by the lines. Select the least number among these numbers, that is, 1 is the least number. Now add 1 in the cells where the lines intersect, that is, choose 4, 3, 3 where the lines intersect. Add 1 to these numbers. Now choose the numbers through which the lines are not passing through. Subtract 1 from these numbers. Hence we get the modified table. Now we have to repeat the process. Choose rows or columns having 1 0 and then go for assignment. Here choose row 1 which has single 0. Mark this single 0. Block the other zeros in the marked column. Choose the 4th row which has one unmarked 0. Mark this 0. Block the other zeros in this marked column. Now row 2 contains one unmarked 0. Choose this row. Mark the unmarked 0 in this row. Block the other zeros in this marked column. Now row 3 contains one unmarked 0. Choose this row. Then mark the unmarked 0 in this row. Block the other zeros in the marked column. Now row 5 contains one unmarked 0. Choose row 5. Mark the unmarked 0 in this row. No 0 elements available in the marked column to block. So we find that all zeros are covered. Now across marked zeros, go for assignment. That is, M1 can be assigned J2, M2 can be assigned J3, M3 can be assigned J4, M4 can be assigned J5 and M5 can be assigned J1. That is, assignments are given for all the machines by using all the 5 jobs. So, this table gives the minimal assignments. Now, comparing this with the original table, the time of the assignment of M1 with J2 is 5. The time of assignment of M2 with J3 is 7. The time of assignment of M3 with J4 is 6. The time of assignment of M4 with J5 is 5, and the time of assignment of M1 with J1 is 4. So, therefore, the minimal time required will be 5 plus 7 plus 6 plus 5 plus 4 is equal to 27. In this session, I introduce you to the assignment problems and how to solve these assignment problems using Hungarian method. We shall work with another assignment problem in the next video session. Thank you.